The first derivative test. Okay, so I don't know how much of this I would write down if I were you, but let's just talk about it. What I want you to write down is what I'm covering up, okay? Let C be a critical point of a function, okay? F is continuous on the interval I containing C, okay? So we have a continuous function, C is a critical number. Maybe that's what I would write down. F is a continuous function, C is a critical number, or critical point. C can be classified as two different things, or nothing at all. But let's go over to the problem that we did on the board here. If my function is increasing, but then it starts to decrease, what's happening? What occurs in between that time? A relative maximum. And if my curve is decreasing and then starts to increase, what's happening? A relative minimum. If we know information about increasing and decreasing intervals, can we identify relative minimums and relative maximums? Yes, we can. All right. So if you notice that your derivative changes from negative to positive, then you have a relative minimum, because that means we are switching from decreasing to increasing on our function. And the other way, if you have a critical number and our derivative changes from positive to negative, we have a relative maximum, because our function is changing from increasing to decreasing. Note, if there is no change in sign, then we don't have relative extrema. That's just a music note. You don't have to draw that. Just note. Okay. We are not doing anything different than we did yesterday. We're just adding one extra step of identifying relative minimums and maximums. Now, on Monday, we talked about absolute extrema. And we had like one minimum, one maximum. Relative extrema, we're talking about we could have multiple, and they don't have to be the extreme highest or the extreme lowest. It's just when we have that switch of direction. Okay? So, let's go through a simple polynomial problem. Okay. What I have for us first is I want us to find the intervals in which this function is increasing and decreasing. So write it down. Welcome back. This one that we had yesterday, or no?
I don't think so.
It's different?
We did have it yesterday.
Okay. That's what I thought. So yesterday we found the derivative. We found where the derivative was equal to 0. We placed our critical numbers on the number line, and we determined where we had increasing and decreasing intervals. Okay? That's where you stopped yesterday. Well, technically you wrote, we're increasing from negative infinity to negative 2 and to the infinity, and we are decreasing from negative 2 to 2. That's where you stopped. Okay? Now, one step further, the first derivative test. Okay? What's happening at negative 2? Our derivative is changing from positive to negative, which means our function is changing from increasing to decreasing, meaning we have what occurring? We have a relative maximum at x equals negative 2. Okay. If I ask you to justify your answer, your justification is that the derivative changes from positive to negative. Please use words when you justify. I do expect like full words. I'm okay with f prime of x, but don't write plus and minus. Please. Write words. Okay? What's happening at x is 2? Our derivative is changing from negative to positive, which means our function is changing from decreasing to increasing. What's happening? Okay? We have a relative minimum at x equals 2. If I ask you to justify your answer, your justification is that our derivative is changing from negative to positive at x equals 2. Okay, one extra step. Biggest thing though is I will ask you to justify your answer. And if we're talking about a relative minimum with the first derivative test, your justification is the same every time. If we're talking about a relative maximum with the first derivative test, your explanation, your justification is the same every time. Right? We did this problem yesterday. All right, I wanted to save some time on the algebra part so we can talk about the part that is new. Okay. So I'll just remind you that yesterday we found the derivative by doing the power rule and applying the chain rule. So our derivative turned out to be 4x over 3 times x squared minus 9 to the 1/5. Then we found our critical points. Our critical points were x is 0 because that's where our derivative was 0. And then plus or minus 3 because that's where our derivative was undefined. Okay. All review from yesterday. We placed these numbers on a number line. And then we tested our intervals. Okay. On the previous slide, yes.
We kind of changed the yesterday it was x minus 9, and it's x minus 4. Let's see what we x squared minus 4.
Oh, well then let's do it as 9. Yesterday was 9.
Yeah, okay.
Let's keep it as 9. Thank you. I overlooked that. Okay, so now it's exactly like yesterday. On the previous slide, we had to find the x value of the minimum and maximum. Here, I'm asking for a relative extrema. So if I ask for a relative extrema, I actually want the coordinate. Okay? Now, I don't mind you making notes right here. All right? At -3, we're switching from positive to negative on our derivative graph. That means what is happening at -3? We have a relative maximum. Same thing is happening at +3. Our derivative is changing from positive to negative. We're going to have a maximum. At 0, our derivative is changing from negative to positive, which means we're going to have a minimum. So I just made little notes to myself. All right? But now I'm going to officially write them down. Okay? That's not an acceptable answer. Okay? That's just kind of some notes as you're doing your work. Now what we need to do is you need to tell me the coordinates of your maximum. And you need to tell me the coordinates of your minimums, or minimum. If I want to know the coordinates of my minimums and maximums, what am I going to do with the numbers 3, -3, and 0? Plug them into the function. If I plug them into the derivative, we're going to get 0 or undefined because they're our critical values. All right? We need to go back to the function. So let's do that. If we go back up to the function and plug in -3. -3 squared minus 9 is 0. To the 2/3 is -3, 0 is a maximum, relative maximum. Okay? 3 squared minus 9 to the 2/3. 0, 3, 0 is a relative maximum. Here's where it gets fun though. 0. Right? So we have -9 to the 2/3. Which really just means what? Cube root of 81. If I ask for justification, our relative maximum justification is our derivative is changing from positive to negative. Our relative minimum justification is that our derivative is changing from negative to positive. All right, let's do a problem we haven't done before. This will be our last algebraic example. And I'm actually going to change it. Oh, dang it. Sometimes I make changes and then, like, they don't save. So I want this to be x squared plus 1 over x. That must have happened on this notebook file. So there's been 2 things. That's it. X squared plus 1 all over x is what I want that to be. Okay, so I want everyone to take a moment and find the derivative. Let's see. When you have your derivative, I want you to compare it to your neighbor. Eli, what's your simplified derivative? X squared minus 1 all over x squared. Do you agree with Eli's derivative? What? Do we agree? Okay, so I got distracted with that. Okay, here's our derivative. So our critical points. Where is our derivative undefined?
0.
Where is our derivative 0? Plus or minus 1. Isn't it nice that we can do some of the work in our head a little bit, right? Do you remember when you have to like write down every single step? Now there are a couple things that are acceptable, right? Okay, if you write down that work, no judgment, okay? But you can also do a little bit in your head. That's okay. Number line, label it F prime because tomorrow we're going to work with the second derivative, right? We have -1, 0, and 1. Let's work with the outsides first, because those are the easy numbers to plug in, right? If we plug in 2, because that's to the right of 1, 2 squared minus 1 over 2 squared, is that positive or negative? Positive, all right? -2, -2 squared minus 1 over -2 squared. Also positive, we have some symmetry going on here. Oh, gosh. All right, 1/2. 1/2 squared minus 1. Negative over 1 squared will give us a negative fraction. -1/2. Same thing's going to happen. Okay. So first of all, if I were to ask you for decreasing integrals, are you going to tell me -1 to 1? No. You would tell me -1 to 0 and 0 to 1. Go back up to our original function. What is happening at 0? Okay, we have an asymptote because it's undefined. All right? Now, an asymptote will always be a critical number because that is where the derivative would be undefined. We can't take derivatives at asymptotes. But it can break up your increasing intervals, right? It could increase on one side but decrease on the other side. We don't know, so we have to check. All right? So how many relative extrema do we have? We only have 2. Whoever whispered that. Say it louder with confidence. Okay? What's happening at -1? We have a relative maximum. What's happening at 0? Tricked you. Nothing's happening at 0. What's happening at 1? A minimum. Okay? So we have a relative maximum at -1 something, and we have a relative minimum at +1 something. When we plug in -1, what do we get? -2. And when we plug in +1, what do we get? All right, we have 10 minutes left. That was our last algebraic example. I'm going to take 2 minutes to go through a non-algebraic example and then give you an opportunity to practice a different non-algebraic example. So please draw this graph sketch it. It doesn't have to be beautiful. I really wouldn't even worry about numbering your axes except for the x-axis. Okay? But please make sure you label f prime, that this graph is f prime. Okay. In your warm-up problem, I asked you to identify from a derivative graph where we had increasing and decreasing intervals, correct? Okay, if I asked you to do that here, we would be increasing where the derivative is positive and decreasing where the derivative is negative, right? So I have positive derivative here, negative derivative here, positive derivative here, and negative derivative here. Do you agree? You could even make a number line if you really wanted to, right? If you really wanted to, you could say this. Okay? Now, I don't think it's necessary to write a number line, but if it helps you, you can. I think you can look at the graph, right? Where do we have a relative maximum? X equals -1. X equals +1 because our derivative is changing from positive to negative. We have a relative minimum at x equals 0 because our derivative is changing from negative to positive. All three of those numbers correspond to what on the derivative graph? The 0. Okay, where the derivative is 0, we have critical points, right? Okay. This is your job for me. And I'm going to ask you to do it in a weird order. Each question is asking the same thing. I am asking you for increasing and decreasing intervals as well as minimums and maximums. Now, do I know the coordinate of these minimums and maximums on the example on the board? No, because we have the derivative graph. If we have the function, yes, we can find the y coordinate. If we have the derivative and the derivative only, we only know the x coordinate. So what I'd like you to do at your table is to do number 1, which is the function graph, and then number 3, the derivative graph. But together.